Hello and welcome to another Let's Study video on Introduction to 3D Game Programming with DirectX 12. We just finished the preface in the previous video and we are now continuing on with the introduction and chapter 1 of part 1. DirectX12 is a rendering library for writing high-performance 3D graphic applications using modern graphics hardware on various Windows 10 platforms: Windows Desktop, Mobile, and Xbox One. Direct3D is a low-level library in the sense that its application programming interface, API, closely models the underlying graphics hardware it controls. The predominant consumer of Direct3D is the games industry, where high-level rendering engines are built on top of Direct3D. However, other industries need high-performance interactive 3D graphics as well, such as medical and scientific visualization and architectural walkthrough. In addition, with every new PC being equipped with a modern graphics card, non-3D applications are beginning to take advantage of the GPU, or the graphics processing unit, to offload work to the graphics card for intensive calculations. This is known as general-purpose GPU computing. And Direct3D provides the Compute Shader API for writing general-purpose GPU programs. Although Direct3D 12 is usually programmed from native C++, the Sharp DX team is working on a .NET wrappers so that you can access this powerful 3D graphics API from managed applications. This book presents an introduction to programming interactive computer graphics with an emphasis on game development using Direct3D 12. It teaches the fundamentals of Direct3D and shader programming, after which the reader will be prepared to go on and learn more advanced techniques. The book is divided into 3 main parts. Part 1 explains the mathematical tools that will be used throughout the book. Part 2 shows how to implement fundamental tasks in Direct3D, such as initialization, defining 3D geometry, setting up cameras, creating vertex pixel geometry and compute shaders, lighting, texturing, blending, stenciling, and tessellation. Part 3 is largely about applying Direct3D to implement a variety of interesting techniques and special effects, such as working with animated character meshes, picking, environment mapping, normal mapping, real-time shadows, and ambient occlusion. For the beginner, this book is best read front to back. The chapters have been organized so that the difficulty increases progressively with each chapter. In this way, there are no sudden jumps in complexity, leaving the reader lost. In general, for a particular chapter, we will use the techniques and concepts previously developed. Therefore, it is important that you... I guess I'm still tired. Therefore, it is important that you have mastered the material of a chapter before continuing. Experienced readers can pick the chapters of interest. Finally, you may be wondering what kinds of games you can develop after reading this book. The answer to that question is best obtained by skimming through this book and seeing the types of applications that are developed. From that, you should be able to visualize the types of games that can be developed based on the techniques taught in this book and some of your own ingenuity. Intended audience. This book was designed with the following 3 audiences in mind: intermediate level C++ programmers who would like an introduction to 3D programming using the latest iteration of Direct3D; 3D programmers experienced with an API other than DirectX, for example, OpenGL, who would like an introduction to Direct3D12, and experienced Direct3D programmers wishing to learn the latest version of Direct3D. Prerequisites. It should be emphasized that this is an introduction to Direct3D12, shader programming, and 3D game programming. It is not an introduction to general computer programming. The reader should satisfy the following prerequisites: high school mathematics, including algebra, trigonometry, and mathematical functions, for example. 2. Competence with Visual Studio. You should know how to create projects, add files, and specify external libraries to link, for example. And 3. Intermediate C++ and data structure skills, comfortable with pointers, arrays, operator overloading, linked lists, inheritance, and polymorphism, for example. And 4. Familiarity with Windows programming with the Win32 API is helpful but not required. We provide a Win32 primer in Appendix A. We have required development tools and hardware. The following are needed to program Direct3D12 applications. We need Windows 10, a Visual Studio 2015 or later, and a graphics card that supports Direct3D12. The demos in this book were tested on a GeForce GTX 760. Using the DirectX SDK documentation and SDK samples, Direct3D is a huge API, and we cannot hope to cover all of its details in one book. Therefore, to obtain extended information, it is imperative that you learn how to use the DirectX SDK documentation. The most up-to-date documentation will be available on MSDN, Microsoft Developer Network. Figure 1 shows a screenshot of the online documentation. The DirectX documentation covers just about every part of the DirectX API. Therefore, it is very useful as a reference. But because the documentation doesn't go into much depth or assumes some previous knowledge, it isn't the best learning tool. However, it does get better and better with every new DirectX version released. As said, the documentation is primarily useful as a reference. Suppose you come across a DirectX related type or function, say the function ID3D12 device create committed resource, which you would like more information on. You simply do a search in the documentation and get a description of the object type, or in this case, function. See Figure 2. In this book, we may direct you to the documentation for further details from time to time. We would also like to point out the available Direct3D12 sample programs that are available online here. We have a GitHub repository on DirectX graphic samples. More samples should come in the future, and also be on the lookout for Direct3D12 samples on NVIDIA's, AMD's, and Intel's websites. Clarity. Although we strive to write efficient code and follow best Direct3D12 programming practices, the main goal of each sample program is to demonstrate Direct3D concepts or graphics programming techniques. Writing the most optimal code was not the goal, and would likely obfuscate the ideas trying to be illustrated. Keep in mind, if you are using any of the sample code in your own projects, as you may wish to rework it for better efficiency. Keep this in mind if you are using any of the sample code in your own projects, as you may wish to rework it for better efficiency. Moreover, in order to focus on the Direct3D app API, we have built minimal infrastructure on top of Direct3D. This means we hard code values and define things in the source code that might normally be data driven. In a large 3D application, you will likely implement a rendering engine on top of Direct3D. However, the topic of this book is the Direct3D API, not rendering engine design. And we have sample programs and online supplements. The website for this book, www.d3dcoder.net and www.mercklearning.com, plays an integral part in getting the most out of this book. On the website, you will find the complete source code and project files for every samples in this book. In many cases, DirectX programs are too large to fully embed in a textbook. Therefore, we only embed relevant code fragments based on the ideas being shown. It is highly recommended that the reader study the corresponding demo code to see the program in its entirety. We have aimed to make demos small and focused for easy study. As a general rule, the reader should be able to implement a chapter's demos on his or her own after reading the chapter and spending some time studying the demo code. In fact, a good exercise is trying to implement the samples on your own using the book and sample code as a reference. Then we have Demo Project set up in Visual Studio 2010. The demos for this book can be opened simply by double-clicking the corresponding project file or solution file. This section describes how to create and build a project from scratch using the book's demo application framework using Visual Studio 2015 VS15 as a working example. We will show how to recreate and build the box demo chapter 6. We start with download the book's source code. First, download the book's source code to the sum folder on your hard drive. For the sake of discussion, we will assume this folder is C D3D12 book. In the source code folder, you will see a list of folders for each chapter. Each folder contains the code projects for the given chapter. Note also a folder called Common. This book contains shared source code that is reused in all of the demo projects. Now, in the source code folder, create a new folder where you want to store your demos. For example, C D3D12 book/my demos. This folder is where you create new projects based on the book's sample framework. Okay, so let's do this. Oh no. Okay. Yes. I've seen this before. So let's download this code. Let's go back to the book. We're going to download the book source code. It looks like someone has... Okay, well, here's the visual book site. Oh, this is interesting looking. Look at that picture. Hmm. And we have the source code. Now what does it describe it as? D3, D12 book. D3, D12 book. Let's copy both of them. Let's extract this. Here we are. And for example, my demos. Let's go back to the book. First, download the book source code to some folder on your hard drive. For the sake of discussion, we'll assume the folder is here. We placed it there on our C drive. In the source code folder, you will see a list of folders for each chapter. Chapter 1 through 23, Common, and Textures. Now in a source code folder, create a new folder where you want to store your programs. For example, D3, D12, book, my demos. This folder is where you will create new projects based on the book sample framework. So we want to create a Win32 project. So let's open up Microsoft Visual Studio. File, new project. So what we are going to do is we're going to create a new project. Windows Desktop Wizard. Next. We want to place it in our program. So this would be this PC, our D3, D12 book, my demos will be in this folder. The project name will be, well, what are we trying to do? With box demo. So we'll just say this, called it my box. This will be a desktop application and an empty project. Hit OK. At this point, you have successfully created an empty Win32 project, but there are still some things to do before you can build a DirectX project demo. Linking the DirectX libraries. We link the necessary libraries through the source code using the hashtag programma in common d3d app.h like so. For making demo applications, this saves us from the additional step of opening up the project property pages and specifying additional dependencies under the linker settings. Finally, our project setup is complete. We can now add our source code files to the project and build it. First, copy the box demo source code, chapter 6, boxapp.cpp, and the shaders folder to your project's directory. So, which one was it? Box demo. Box demo. Chapter 6. Box. So we want shaders and boxapp.cpp. So I select both of those, copy them, go to my demos, my box, and place them here. After you copy the files, follow these steps to add your code to the project. Right-click on the project name under the Solution Explorer and select Add Existing Item from the drop-down menu and add boxapp.cpp to the project. So here's our project. Go to Source Files, right-click, Add Existing Item, and then we want the boxapp.cpp. And add, and it should open it up or not. I'll double click it to open it. Here we are. So it looks like we go up, oops, up, common D3D app. Now let's see if that's gonna work. So if we're here and we go up, we do have common. Okay, that looks good. That should work. And it looks like we have the program here. Modest, nearly 500 lines. Right-click on the project name under the Solution Explorer and select Add Existing Item. Navigate to where you place the book's common directory code and add all the .h.cpp files from that directory to the project. Your Solution Explorer should look like Figure 6. Okay, so let's do that. Header files, add existing item. We go upper folder, common, grab all these and add. There we are. Let's go back to the book. Well, it looks like I added all the headers in the wrong one. That's okay. We'll grab these CPPs and drag them to the source files. So let's see if that looks like what we're looking for. Okay, that's looking pretty much one-to-one. Camera, D3D app, D3D app, D3 util, D3 util, D3 DX12, D3 DX12, DDS, DDS, game timer, geometry generator, math helper, upload buffer, box app, camera, D3D app, D3 util, So that looks right. Right-click on the project name under the Solution Explorer and select Properties from the context menu. Under Configuration Properties General tab, you want to make sure the target platform version is set to version 10.x to target Windows 10, then click Apply. Okay. Solution Explorer, right-click, Properties. Configuration Properties. Nope, I'm already lost. Hold on. Yep. Right click, Properties, Configuration Properties, General tab. Project name. I guess my box. Properties. Configuration properties. General. Windows SDK version 10.x or 10.0. Latest install version. Okay, that's good. Target platform version is set to 10.x. I don't see target. General properties, Windows SDK version. Target platform version. I don't see it, but I do believe that this is the answer that we're looking for. The Windows SDK version. Source code files are now part of the project, and you can now go to the main menu and select Debug, Start Debugging to compile, link, and execute the demo. The application in Figure 7 should appear. So we should be getting this function right here. So if we press this button, Local Windows Debugger, it should work. So we have these build errors. I understand these guys. The C2102, the AND requiring an L value. So if we go and check here, we have these addresses to these results. I know the answer to get rid of that. I don't know about fixing it, but the answer to get rid of it is we go down to C and C++, and we go down to general. Where is the permissive? Language, conformance mode. We can do no. Apply. Hit OK. And then we should be able to run. Okay. It looks like we have our box with a casual couple thousand FPS. A random cube. I really like this blue corner. Very vibrant. Very colorful. Whee! So that's working. Pretty hassle-free. Alright. So we have now the source code for we have the source code now from the book. We are able to copy the source code into our own projects for us to tinker with. And we are now at part 1, the mathematical prerequisites. I'm going to leave it here and get some rest. It's already nearly 7 a.m. And we'll pick this up tomorrow and continue on. That was rather painless getting this set up. I am curious to know, and please in the comments below, if you have an answer for the conformance mode and why setting it to no gets rid of those errors. The C2102 errors. And allows us to build and run. Thank you for watching. I hope you found this informative. And good night.